Okay, so for example number 1, we're using a direction field to sketch a solution curve. So for part A, we want to be able to sketch the direction field for the differential equation y prime, which is equal to x squared plus y squared minus 1. So we're going to start by computing the slope at several points in the following chart. If we substitute x to be -2 and y to be 0, we're going to get 4 plus 0 minus 1, which gives you 3. So I'm going to concentrate on that first point. And so I'm going to highlight this, and you can see that with the points -2 and 0, we end up getting a slope of 3. So what we're going to do is, on the x and y axis here on figure 5, we're going to go to that point where we can find -2, 0. And then you see this small little segment here, okay, that I highlighted. That represents a small line segment that has a slope of 3 at that point. Okay, let's move on to the next one. Okay, we have x to be 1 and the y value is 0. Now, if we plug that into the function, we're going to get +1 plus 0 minus 1, which gives us a value of 0. So that means we have a 0 slope at that point. So let's go ahead and take a look at that ordered pair. So if we move over to -1, 0, there's a blue line there. You might not be able to see it too clearly, but what that does is it's a horizontal little segment that we created at that ordered pair. Let's continue to do that for another point. Okay, let's take a look at the value 0, 0. Okay, so when x is 0, y is 0. So that means if we plug in 0 into the derivative function, we're left with -1. So that means at the point 0, 0, we should have a -1 slope. So if you take a look at the origin, you have a line segment that has a slope of -1. All right, let's take a look at another point. So if we take a look at, let's see here, the value of 0, 1. So we know that our x represents 0, our y value represents 1. If we plug it into the derivative function, we get 0 plus 1 minus 1, which gives us a slope of 0. So now let's go ahead and find that ordered pair, which is 0 and then 1, and you will notice that there is a blue segment that is a slope of 0. So these ordered pairs are points that are on this directional field, okay? And once you plug in these points into the derivative function, then each of those segments is going to have a slope according to whatever value that you end up getting. So that's how we create a directional field. Now, the next part, and part B, okay, they're asking us to then sketch the solution curve that passes through the origin. Okay, so if we want to sketch a curve that's passing through the origin, I want you to take a look at this. Now, what's going to happen here is that you can pick certain graphs located on this direction field. And the direction field changes direction according to whatever sketch that you draw that's going to pass through the origin. So if we start at the origin and move to the right in the direction of the line segment. So if we start at the origin, the line segment is going down. So it's telling us that we have to go down. Okay? Then if we continue to draw the curve so that it moves parallel to the nearby segments. So this one's got to move parallel to this segment here. And then as it moves over here, then it's got to turn. And then as it keeps going to the segments, it keeps changing according to the little segments, because that's representing the direction field. Now, if we go in the other direction, returning to the origin, and then going through the origin, well, if we go in this direction, again, we're following this curve, and this curve now is parallel to this segment. It hits another segment, and therefore now it's going down, and then it hits those segments and is pointing down all the way towards that segment. Now again, it depends on which segments that you bounce it off of. But again, this is how you sketch the solution curve that passes through the origin. Okay, so let's take a look at an animation of and how to draw a sketch through a direction field. So here we have this model, okay, and what this does, it allows you to investigate direction fields for a variety of first order differential equations in the form of y prime equals f of xy. And then you can view these solution curves through various points on a plane and observe the different characteristics of those curves. So if you look at the top here, the derivative function we have here is x to 2/3 sine e to the x. And so now this is a direction field that's been created. Okay, now if you watch my cursor, okay, what I can do is, let's say if I pick a point like right here, okay, on the top left. Okay, if I select enter, what's going to happen is that from this point, there's going to be a line that follows these directional segments, and it's going to flow wherever the particular graph goes. So I'm going to go ahead and select that, and you can see how it's following the directional field. Okay, it's going back up, and therefore there is your directional field according what's in this viewing rectangle. Let me start another one down here. Okay, actually I'll start one right here. So here I'm going to start my point, and you can see the directional field. Okay, and again, it's following those segments. And you can see what's happening and how the slopes are changing the direction. Okay, likewise, if I start here at the origin, okay, again, it's going to go up and then back down again according to the line segments, because the line segments are making it change direction. And again, because each point has a particular slope. So let's see here. Let's take a look at another one here, 2x plus 3y plus 1. Okay, let's start at the origin again here and see what happens with the directional field. So that goes straight up, because again, that's what's happening with those line segments. Okay, if I start right here, okay, what's happening? It's going down towards negative infinity of the y axis. Okay, if we start here, again, it goes down and then it comes back up. So again, this is how you are sketching a particular graph on a direction field.